So now that we've gotten through our discussion of Java ReentrantReadWriteLock, it's time to turn our attention to the more modern and in many ways more optimized readers-writers mechanism in Java, which is the Java StampedLock. So as always, we'll start out with an overview of its structure and functionality. So as you might expect, the StampedLock implementation provides a readers-writer implementation in Java 8 and beyond, which is more efficient and much more scalable and much more featureful than Java ReentrantReadWriteLock that we looked at before. It does not implement the read-write-lock interface. It does not use the abstract queued synchronizer framework. It does not apply the bridge pattern. It does not pass go. It does not receive $200. It's really stripped down and meant to be very, very optimized and very efficient. What it does do is it provides 3 locking modes. And these modes go well above and beyond what we've talked about earlier with Java ReentrantReadWriteLock. So let's go through the modes. 2 of the modes will look familiar, but they are behaved differently. And then the 3rd mode will be quite different. So we'll start off by talking about writing mode. And as you can see, there's a number of methods that a StampedLock provides to support writing mode: WriteLock, try-WriteLock, and then try-WriteLock that's timed. And as we'll see, writing mode is pessimistic. What that means, again, is it assumes contention will occur so that no other thread can acquire the lock while it's held for writing. So a write lock is exclusive. There's also reading mode with readLock, try-ReadLock, and try-ReadLock with timeouts. Reading lock is also pessimistic. It again assumes contention can occur, although if everybody else is only a reader lock, then everything can proceed in parallel because a read lock is shared. And then the final mode, which is really the different one, is optimistic reading mode. And this is optimistic since the assumptions based on its use case assumes contention will not occur, so other threads can also obtain the lock optimistically. And what we're going to talk about when we go through this in more detail and we look at some examples is an optimistic reading mode is a probabilistic lock, which means we think it might not encounter contention. And as you can see, there's 2 methods that it provides. One is called try optimistic read, and the other is called validate. And the usages of these 2 methods are quite different from the reader and writer lock modes. And so we'll take a careful, detailed look at these things as we get to that part of the overview. As you'll see, it's also possible to convert a lock from one mode to another. So it can go through metamorphosis, it can metamorphize. And we'll see that there's 3 methods that allow that to happen: try to convert to write lock, try to convert to read lock, and try to convert to optimistic read lock. And then we go through the details in later parts of the lesson. We'll see how each of these different methods can be used. So that's the end of the overview of the structure and functionality of Java StampedLock. Hopefully you can appreciate, even with this very brief overview, that it's a bit different from what we've seen earlier with the Java ReentrantReadWriteLock. And as we'll go into more detail when we look at the examples and walk through the key methods, these differences make it quite a different type of mechanism altogether. And so you have to be prepared for the complexity of programming it. But the good news is that your patience will often be rewarded because it's a lot more scalable and a lot more efficient than what we've seen before with Java ReentrantReadWriteLock.